okay, implicit differentiation. So we've got a function here defined implicitly, okay? It's not y equals, isn't it? Okay, because if we had y equals something in terms of x, that would be known as an explicit function. But here, we can't do that. We can't get y equals, okay? So it's all in terms of x and y like this. So that means we've got an implicit function. And we're asked to find dy dx. We're asked to differentiate it. So it's different, isn't it? When you've got y equals to something in terms of x, you can find dy dx straight away. You just differentiate the x functions, yeah? The x terms. In this case though, we can't get y equals, so we've got to use implicit differentiation. First thing you should do is look here to see if there's anything that would cause difficulties. And you can see here we've got a product, okay? So we really need to differentiate this product first, deal with that, because that's going to be a little bit of work before we differentiate the other terms, okay? So if we use the product rule, okay, for this middle term here, so 2xy. Now with the product rule, if you remember, you've got two things times together. So the first thing we'll call u, which will be equal then to 2x. And the second term then we'll call v. So v will equal to y. So you've got your u and v. Of course, these two things are times together. All right. So when we then differentiate, okay, we're going to differentiate the u and we're going to differentiate the v. So if I differentiate the u, I'll get du dx, yeah? Du dx, but you remember from working class, you don't have to write du dx, you can just write u dash, okay? If you remember that, you just write u dash instead of du dx. It means the same thing, okay? It means the same thing, but it's a lot easier if you just put u dash. So differentiate 2x, it just becomes 2. Same thing here, we differentiate this, so dv dx, so just v dash. And we know, of course, y then just becomes 1. But because it's a y term, when you differentiate, you've got to put a dy dx at the end, okay? Because remember, I'm differentiating with respect to x. I want dv dx. So because it's a y term, you differentiate that, and of course it becomes 1, but don't forget to times dy dx. So the product rule, okay, basically if you remember, if you have two functions times together like that, two terms times together, u, v, then the product rule, dy dx, okay, differentiating, which would be the same as y dash, yeah, is quite simply v du dx, so v u dash plus u dv dx, v dash. So in other words, in the case above, I've got v, which is y, times u dash, so that times that, which is 2y, plus this times this, okay, u times d v dx, u times v dash, which will be 2x times this, which is just dy dx, isn't it? Okay. So there you go, there's the product rule applied to this, and I've got my answer there, okay, differentiated. So now I'm going to differentiate the whole thing, okay, so I'm going to say here, I'm going to differentiate with respect to x, okay, differentiating implicitly with respect to x. Now, of course, x squared just becomes 2x, doesn't it? That's easy peasy, okay. 2xy, we've already done it, is here. Three y squared, well, if you differentiate that, you get 6y, don't you? Take the 2 down, so you get 6y, but don't forget to put dy dx on the end, because it's a y term. And then your 12, because it's a constant, differentiate that, becomes 0. Now, the next thing, final step, is to get dy dx equals, okay, so we've got to rearrange terms here, okay, but perhaps before we do that, you might notice this has got a common factor of 2. So if I divide through by 2, okay, I'll get x. Divide that by 2, I get x. Divide that by 2, I get y. Divide that by 2, I get x dy dx. And divide that by 2, I get 3y dy dx. That will all equal to 0. Okay? So then I want to get dy dx equals, so I'll take these terms over the other side. So that becomes minus x minus y. And I take those two terms over. Here I got dy dx in both terms, so I can factorize it out. So here's going to be x, isn't it? Because to get x dy dx, I've got to times dy dx by x. And here, to get this, I've got to times this by 3y. So factorize it out, and then to get dy dx on its own, all I've got to do is, because we're timesing that, so take the whole bracket over and divide. And I've got an expression there for dy dx.